All right, we're going to start talking about functions. We've talked about relations, and now we're going to talk about functions. Functions are related to relations. They're actually a special type of relation that pairs each domain value with exactly one range value. So a function is a relation that pairs each domain value, which is x values, with exactly one range value, okay? So pairs each domain value, that's referring to the x values. So every x value has exactly one y value. All right, so an x value can't have two y values or three y values. An x value has to have exactly one y value. And so that they state that as saying a function pairs each domain value with exactly one range value. All right, let's look at some different examples here. Okay, so the first thing that we have to do for these problems, example 3a, identifying functions, is give the domain and the range of the function. And then after we do that, tell whether the relation is a function and explain. All right, so if you look here, we have 1, 2, 3, 4 ordered pairs. So this is a discrete graph, so we have to make sure that we represent the domain and the range accurately. So the domain, we're going to list the x values in order, right? This is x, 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 okay? In order from smallest to largest. So I'm going to use that set notation. The smallest one I see is 3. It's twice, right? So I'm just going to write it one time. And then there's 4 and then 5. So that would be the domain. Those are the x's. And then let's go ahead and look at the y's, which are here, the y values. And so the group of y values, I'm going to start writing the smallest one, which would be -2. And then the next smallest would be -1, and then 0, and then 1. Okay, so that's the range value. Okay, now we have to tell whether the relation is a function. So that definition, remember, it says a function is a special type of relation that pairs each domain value with exactly one range value. So let's look at these. The domain values. Does this x value have one y value, exactly one y value? If you look at the x value of 3, here's 3, and here's 3, right? That is one x value, right? It's 3. Does it have exactly one y value? No, this 3 has a y value of -2, and this 3 has a y value of 1. So because this domain value has more than one y value, it is not a function. So it says, tell whether the relation is a function. The relation is not a function because one domain value has more than one y value. All right, so there is our answer. Perfect. Okay, let's go ahead and look at the next example. 3b. Give the domain and range of the relation, tell whether the relation is a function, and then explain. Perfect. Okay, so this is nice. We have a mapping, so we know that this is the x and this is the y. It's just how it is. Okay, here's all of our domain values right there. Super nice. Just going to list them out. These represent ordered pairs. There's 1, 2, 3, 4 ordered pairs. And so we need to just write all of the x values, starting from the smallest to the largest. So the smallest would be -8, and then -4, and 4, and 5. So there's our domain values, our x values. And then we have our range values, which are just in order 1 and 2. Okay? Now it says tell whether the relation is a function and explain. So I'm going to look at this first x value, -4. Does it have one y value? Yes, -4 has one y value. It's 2. Does -8 have one y value? Yes, it has exactly one y value, 2. It's okay if those two x values share the same y value. The important thing is that the x value only has one y value. The x value only has one y value. What about here? This 4 has one y value, and right here, this domain has one y value. So, is it a function? Yes. This is a function because every domain value has exactly one range value. All right, that is it. Okay, let's look at another example here. Ooh. So identifying, okay, so example 3C. So again, we're going to give the domain and the range value of the equation, tell whether the relation is a function. So first, I think it's important that you understand what this graph is. So I'm going to do it in orange here. So the graph, this is the graph. I know there's dash lines, and you kind of just need to ignore the dash lines right now. So this in orange is the actual graph that we're going to be doing. It's a shape, right? So you can tell what the, when shapes are, see how they're on the coordinate plane, the x and the y-axis? Shapes can be drawn on the x and y-axis, and when they're on the x and y-axis, you can state what the domain and the range are. So let's go ahead and do that. So here, if you see, I'm going to state the domain first. And so for looking at the domain or the x-axis, I want to know, well, this orange figure, what is the smallest value, x value, that this touches? And so if I go all the way here, I'm coming here on the x value, the graph, there is no graph, there is no graph, there is no graph. Whoa, right here is when I start that, the little piece of orange hits the x. So this is a part of the domain, right? Is when x is -1, -2, -3, -4. This is -5. Right there. So, and then what happens, it keeps having x values or domain values all the way until we get to when x is right here. This is the farthest point over, which is there when x is 1, 2, 3. Okay, so all the x values in the domain, so this would be the entire domain region right here. From the farthest point, this is the farthest point, to the farthest point on the left side to the farthest x point on the right side is here. And so all these values are the domain, okay? So this is actually ends up being an AND problem, so we need to go ahead and write it like that. And so we have D, the smallest is -5, and then we have x, and x is greater than or equal to -5 all the way up to +3. X is less than or equal to 3. So that would be the domain here. It goes all the way, the x values go from -5 all the way to 3. So that would be our domain. And now we're going to look at our range. So our range is all the y values. So you want to look, okay, what's the smallest y value? As we come here, right, this is the y-axis. The smallest y value would be right here, right? So it's right here, and then there's y values all the way until we get to right there, okay? So from here to here, this represents our range. Okay, so our range goes from, this is -1, -2, all the way up to +1. So our range is -2, that's -1, -2, and then it is all the way up to +1. Except we're talking about the y's, so we need to have the y's to +1. So there's our range value. Okay, so we have our domain and range expressed. Now we just need to tell whether this relation is a function. And remember, with a function, every domain value has to have exactly one y value. And so when I'm looking at the domain values or the x values, what I see is I see here 1. Or let's look here at -1. -1 has an orange y value up here, right? Because I can write this point. That point is going to be -1, and that would be +1. That's what that point is. But then it also has a point down here on this orange figure, and this point is again -1, so it shares the same domain value, and it has a different range value of -1, -2. So that means the domain value of -1 has two different range values. So because of that, it is not a function. And sometimes, so what we would say that this is not a function because a domain value has more than one range value, which is the case. This domain value of -1 has two different range values of 1 and -2. Okay, so that's the reason why it is not a function. Now, when you have different types of figures like this or lines, one thing that works as far as telling whether something is a function or not is by using what they call a vertical line test. And what a vertical line test says is, I'm going to just look at this part of the protractor as like a vertical line. So imagine this going across here as a vertical line. Do you see that? It's like a straight line up and down, like those dash lines. That's a vertical line. So look at where the protractor hits the paper, vertical line. So the vertical line test states that if, as you're doing a vertical line, if the vertical line hits the graph in more than one place, then it is not a function. So if we look here, this orange, this vertical line hits the orange right at the corner, so it hits it in one place. But as we move this vertical line over, the vertical line hits the orange here and here. So it hits it in more than one place. And right, this vertical line is actually talking about the range values. So it represents those two different range values. So that would mean that this is not a function. Or here, right? It hits the orange here. This vertical line here hits the orange here and here, so it would not be a function. And then again, here, it's still hitting the orange in two places, still hitting in the orange in two places, still hitting the orange in two places, and then at the very end, it's hitting it in one place, but it's okay. But because that vertical, it hit the vertical line in more than one place at any one point, automatically you know it's not a function. All right. So that's called the vertical line test. Okay, now it is your turn to check it out. I want you to try these two examples. Give the domain and range of each relation and then tell whether it's a function and explain. So, oh, where's my friend? Oh, here's my friend, the pause dragon. Remind you to pause, work out A and B. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, we're back. Let's see how you did. So this first set of ordered pairs, let's find the domain. So we have to list all the x values. Here we have 4 ordered pairs. I'm going to do it in the order from smallest to largest, so I need that set notation. The smallest would be -6, and then -4, and then 1 and 8. Okay, and then the range would be the y values. So it's the group of y. Got to use set notation. I'm going to write the smallest one first, which is 1. And then 2. And there's 2 is written twice, but you only, it's in 2 different ordered pairs, but you only write it once in the range. And then 9. Okay, now we just need to tell whether each relation is a function and explain. So for the value of -6, remember the definition is every domain value has to have exactly one range value. So does this domain value of -6 have one range value? Yes, it does. 2, there's no other -6s. What about -4? Yes, it has one y value. There are no other -4s. What about 1? Yes, 1 has one y value of 9. And lastly, what about 8? Yes, 8 has one y value, and there are no other 8s. So yes, this would be a function. So yes, a function, because every domain value has exactly one y value. Perfect. Okay, let's go ahead and see how you did. So there's our answer here. Okay, let's see how you did on B. Okay, so I love these because you always know that with the mapping, that's the X, and this is the Y. And really, there's the whole domain right there. Whoops, sorry about that. So I'm just going to write those domain values from smallest to largest. So 2, 3, 4. And then write the range values from smallest to largest. So -5, -4, -3. All right, and then we just need to tell whether it is a function. So every X domain value has to have exactly one Y range value. So this domain value has one range value. This domain value has one range value. This domain value actually has 2 range values. Therefore, this is not a function. So not a function because one domain value of 2 has more than one range value. All right, so if you got those and those explanations down and correct, great job. Let's go ahead and I want you to try a couple more out. So I want you to try check it out example 3 here, and also check it out example 3, check it out example 3C, and check it out example 3D. So here's my friend the Pause Dragon. Remind you to pause your device, work out those problems. When you get done, press play and we'll go over the answers together. All right, let's see how you did. So first we have to give the domain and the range of each relation. So as I'm going, the domain is the X values, right? The smallest X value starts here, right? The graph is here and here. And then the X values keep going until right here. This is the farthest point on the right. So the X values go from here to here. So this is really one of those and problems again. So the smallest X value is going to be -2. We're talking about the X values. So X is greater than or equal to -2 all the way. Oh, wait. No, this is -1, -2, -3. So this is actually -3 all the way up to 1, 2. So X is less than or equal to 2. It doesn't go over 2. So those are the domain values. And then the range values are the Y's. And the smallest Y value starts right here on this graph. And then all of these values go all the way up until this very tippy point right here. And that is the largest Y value or range value. So the range value starts here when Y is -1, -2. And then we're talking about y, right? So y is greater than or equal to -2 all the way up to when y is 4. So y is less than or equal to 4. So y is greater than or equal to -2 and less than or equal to 4. Okay, that is the range value. So now we need to figure out if this is a function. So that means for every domain value, there has to be exactly one y value. And so as I'm looking here, at my domain values, here my domain value of 1 has a y value here, and it also has a y value here. I can write that as 1, you know, it's probably 2.1 or something, and then down here it's 1 and -1, -2. So the domain value of 1 has 2 different range values, therefore it's not a function. And if we went ahead and tried that vertical line test, you would see that the vertical line touches the point, the graph here and here, so in 2 different places, so therefore it would not be. And see 2 places again, 2 places here, 2 places here, and then a whole lot of places there. So this is definitely not a function. So we are going to write not a function because domain values have more than one range value. Perfect. Okay, so if you got that one right, awesome job. Let's go ahead and look at check it out example 3D. So for 3D, I love these because we have the domain and the range right here. So let's just go ahead and write that domain. 5, 10, and 15, right? We just have distinct ordered pairs, so it's going to be discrete. So we have to make sure that we do the discrete format, where there's a continuous line, so that's why you have to make sure that you use the and notation when you're doing the compounding inequalities here, because it's a continuous relation. All right, so we have the domain values. Now let's go ahead and write the range values, which are all right here. So 2, 4, 6, 8. And then we just need to tell whether it's a function. So does this x value have one range value? Yes, it has. This domain value has one y value, but it also has a second y value. So there we have it. This is not a function because this domain value has more than one range value. So we would say not a function because a domain value of 5 has more than one range value. All right, so if you got that right, great job. If not, go ahead and fix your notes so they look exactly like mine. Yeah, so just if it doesn't look exactly like mine, just go ahead and fix it so that your notes match up with mine. All right, that is it for this lesson. I will see you back soon for Chapter 3, Lesson 3.